Okay, so of course, what is EMC now? So we go a bit more on, a little bit on theory. Okay, electromagnetic compatibility. Okay, means that when you have a product, okay, the product is not a source of a noises to the environment. Okay, and also the product must be immune. Okay, when you are in a noisy environment. Okay, so this is where we do emission tests and we do immunity tests, such as EMC. Okay, so we have emission tests. So in emission means that we measure the noise. So we measure from RF and non-RF, such as harmonics and flicker. And the same product, okay, need to be immune. So immune means it got to be susceptible, okay, from the same similar noise, from the RF noise and from the high power, high voltage noise, such as the ESD, surge, and burst.
Okay. Trách nhiệm của chúng tôi trong giải pháp, trong việc cung cấp giải pháp EMC đó là đưa ra các giải pháp chìa khóa trao tay từ các nước bán hàng lên kế hoạch tích hợp hệ thống cho tới việc lắp đặt, đào tạo cũng như là các dịch vụ sau bán hàng, thì chúng tôi là nhà cung cấp các giải pháp toàn bộ gói giải pháp chìa khóa trao tay, cũng như là chúng tôi hợp tác với lại các hãng trên toàn thế giới, các hãng hàng đầu trên toàn thế giới, từ Mỹ, từ Nhật Bản, Đức, vân vân. Vậy tiếp theo là phần định nghĩa EMC là gì? Thì khả năng của định nghĩa về EMC đó là khả năng của một hệ thống điện tử. Thứ nhất, không phải là nguồn gây ô nhiễm điện từ trong môi trường xung quanh. Có hai phần, đó là phần kiểm tra phát thải hay được gọi là kiểm tra EMI. Phần thứ hai là nó phải hoạt động đúng trong môi trường điện tử, thử nghiệm khả năng nhiễm, khả năng nhạy cảm, cũng như là còn được gọi là xét nghiệm EMS hoặc là immunity testing, xét nghiệm miễn nhiễm. Thì đây là sơ đồ về cơ bản về các cái bài test EMC.
Okay, so when we talk about testing EMC, it's always talk about what standard we test to. Okay, so these are some of the typical, the common EMC standards is available. Of course, there are much more standards. Okay, so for example, you are making what kind of products? Okay, so if you are making products like industrial scientific measuring equipment, ISM. Example, a keysight spectrum analyzer. Okay, it is not a household equipment. You don't use at home. Okay, you don't use anywhere. It's categorized under industrial and scientific measuring equipment. So the keysight spectrum analyzer need to do EMC tests himself. Okay, so they need to comply with SCETPA 11. So if you make a product like a household product, like an air conditioner, okay, or washing machine, then you need to comply to SCETPA 14. So this is only the emission. Okay, so emission and immunity have a different standard. Okay, so this is immunity. For example, for household is SCETPA 14-2. For multimedia equipment, example your TV, the new TV, television, your hi-fi systems, okay, is for multimedia. And automotive, okay, automotive components like the components that you put in the car, the radio in the car, the meter in the car, okay, we need to do EMC as well. So this is just an example of the automotive EMC standard, okay, that is commonly used. ISO 11451-X for full vehicle, and for components we have ISO 11452. Okay. Then example, okay, different countries have their own regulation. Okay. So for example, in USA, okay, the regulation governs by FCC, Australia EMC framework, okay, Japan is VCCI, for China is the GB standard, Malaysia MS standard, okay, Vietnam is by QCVN, so you have a QCVN standard. For Thailand, you have TC. So every country will have their own standard, okay, which is usually they adopt from the international standard and they convert to local language, okay, and maybe some changes, okay, for local, the local country's requirement, okay, then they will come up with their own standard. Okay, of course, some other standards, okay, for different products, okay, military, okay, so have their own standard. For MIL standard 461, for avionics, okay, avionics means like aeroplane, helicopters, okay, DO-160, okay, and then for telecommunication products, okay, from ETSI 301XXX, so they have so many different type of telecommunication products, for Bluetooth product, for Wi-Fi product, for GSM, 2G, 4G, 5G, 6G, 7G, maybe in the future. So it's usually is under the ETSI standard for wireless products. So EMC is about testing to the standards. So now we focus into one section first. Okay, we talk about emission. So in RF, okay, what is RF noise? Okay, at first we want to know what is our wanted RF first. Okay, we want RF signal. It's not that we don't want RF signal. We want RF signal. We want Bluetooth. We want Wi-Fi. We want GSM that is ringing. Okay, so we want radar. We want the walkie-talkie signal. So all these are the wanted RF that we want. But unfortunately, when you make a product, okay, electronic system, you will always have noise, okay, in the electronic boards, your power supply, okay, your harmonics of the wanted signals. Okay, these are the unwanted noise that we don't want. And the standards will tell you how much of the noise you should not exceed the limit. This is where we want to measure. Okay, so why we want to limit? So we want to protect, okay, all the radio and TV broadcast frequencies. Okay, we want to keep, okay, the radio spectrum clean and organized. This is why Bluetooth, you have a specific frequency band you can use. Wi-Fi, you can have a frequency you can use. The 2.4 gig, okay, 5.4 gig. GSM is always 900 meg. Okay, so everybody use the same frequency band. Your FM is 80 over to 90 over megahertz. So everybody will use the same frequency band. Okay, so it is organized, it's all the frequency band. Okay, so but when you have noise, okay, so example, you have a noise of a product, like for example, a projector is 900 megahertz. It's very high. Nobody here will get telephone signal in the GSM because the noise at the 900 meg is very high in the projector. Okay, so everybody will cut off from the signal. Okay, this is something that we don't want. So it makes the system, okay, the RF system haywire. Okay, so how does RF will be transmitted? So a few ways. Okay, of course, it will radiate by the air that you cannot see. Okay, from air, okay, from a product to a product, and of course, when the product is connected to a power line, okay, so RF will flow from the RF, from the cable, okay, to the power line to affect another instrument. And when the cable is laid long, okay, it reacts as an antenna, okay, so we have noise from the cable itself. And the RF noise will flow into the mains to whichever is connected. Imagine you have a very noisy equipment, okay, and it affects everybody in the network that you connect. Okay, this is where now we want to measure all the noise so that it does not exceed the limits. Okay, so how do we measure the noise? Of course, you have a source. Then how does it transmit? Okay, either by the cable, by the air, and we have transducer. Transducer means we use what apparatus, like antenna to measure, or we use a network to measure, and typically we use spectrum analyzer, or a full compliance, we use EMI receiver to do all the measurement. Okay, example of how you measure conducted emission. So conducted emission usually is at a low frequency. So you have a laser, okay, so we have an EMI receiver, okay, then you have a measurement set up with a ground plane, okay, then we do the measurement. Okay, so another measurement, okay, this continuous measurement, okay, mainly for household appliances like air conditioning with switching mechanism, okay, washing machine, aircon, okay, click measurement, okay. So we will have another topic, okay, talking about this measurement later by Dr. Michele. Then, of course, just now we talked about when the noise is radiated from the cable, okay, we use a clamp method, okay, to do the measurement, and this frequency becomes higher already, okay, because it starts to radiate through the air, okay, frequency starts from 30 megahertz to 300 megahertz, okay. So now radiated emission, okay, which I can say one of the more expensive system in the EMC measurement, okay, where now we measure high frequency, okay. So how do we measure is usually we have an antenna, okay, say we have the EMI receiver with the correct frequency range that we want to measure, okay, and we have an environment, okay. So now we have a product under test, the equipment under test, okay, and we want to measure the direct wave of the noise and the ground reflected wave of the noise from the EUT, okay, and then we will turn the EUT 360 degrees, so all angle we want to measure, okay, and we need to scan from 1 meter to 4 meter. Generally, in the olden days, okay, we do measurement in the open area test site. So I'm not sure if anybody's seen or used open area test site before. Okay, so open area test site is just open area, okay, where you make a ground plane, okay, then you can turn your product, okay, your antenna can move up and down 1 meter to 4 meter, okay, and best is environment is good, okay, clean from external noise, okay, and it is nothing at the site. But can you find something like this in the modern world? Okay, you come here, you will have your handphone signal, you have your mobile phone signal, you have your radio signal, everything is here. Okay, so we have a lot of unwanted noise. Okay, then raining, you cannot do measurement. Okay, so it's big problem also. Okay, that is why now in all EMC setup, okay, I will say 99%. We still have 1% that people do open area test site. Okay, but if raining now, like now it's raining, you cannot do. You just in the office, do nothing. You cannot do measurement. Okay, now they built anechoic chamber. Okay, so either you build a semi-anechoic chamber or you build a full anechoic chamber, so it depends on your application. Okay, then you do the measurement inside the building. Okay, so the EMC anechoic chamber mainly is two materials. Okay, so one, we use the shielding group, means we shield the roof from all the internal to external noise. So it means that inside is block all the RF from outside to inside. So it is a clean, okay, for RF. And then we have absorbers, okay, inside. So to reduce all the EM reflection wave. Okay, so some examples, okay, of anechoic chamber pictures, okay, some setups, okay, some pre-compliance small chambers, some big chambers, okay, so it depends on the test requirements that you have. Okay, some even bigger chambers to put the car, to put the tank, okay, for military application, okay, and even bigger, okay, you can put aeroplane. So depends on the application, okay, what you make. Okay, you make aeroplane, you cannot build in a small chamber. You need big one, like this. You make small, you make TV, okay, or you make radio, then you can put inside a small one. So depends on the application, how you want and how big is your product. Then we can build according to what you want. Okay, so from small product, okay, to bigger like car, okay, to aeroplane. Okay. Then of course, another way, okay, some standard is full compliance, most standard is free compliance. Okay, you build a chamber is very expensive. Okay, so we have a way, okay, for you to do some free compliance test. Okay, to build a G10 cell. So this is something like a chamber. Okay, but the product is very small. Okay, you can put in a small. So it's something like it can be as big like this, or you can put it on top of the table. Okay, a few different sizes. Okay, so it is for pre-check. Okay, but some standard already allow this measurement as a full compliance measurement. Okay, so finish about RF emission. Next, a product. Imagine a product. What else? Okay, it will create noise. So in the harmonics means the noise in the power line. Okay, this is not RF. So we measure the harmonics. Okay, so it's power analyzer. Okay, we measure all the harmonics in the power line. Okay, to ensure that it is within the measurement standard. Okay, so we limit. Okay, so we have a 61,000-3-2 for the harmonic standard. Okay, for equipment that is below 16 amps. Okay, above 16 amps is 61,000-3-12. Okay, then depends on what type of product, okay, you are at. Okay, what type of product is you want to test. Okay, for example, class D. If you're making TV, you're under category class D, then you have a class D limits. Okay, your noise should follow class D. Lighting, okay, follow the class C. Okay, class B, class A. So it depends on the product. Okay, what product you do, then you follow what category. Then which category will give you a different kind of limit. Okay, flicker is when your product will create a voltage fluctuation in the power line for you. Okay, so we want to measure the voltage fluctuation in the power line. So this is where we measure the flicker. Okay, so mainly about voltage fluctuation. Okay, so voltage will go down, then will go up again. So it means that it will make the power supply system unstable because the product make the power voltage is unstable in the power line, in the grid. So we want to measure this as well. Okay, some systems, so we have a single phase or three phase kind of systems. Okay, so it depends on capacity. Okay, whether the product is single phase or three phase. Okay, so we measure the harmonics and flicker. So now we finish about the emission. Okay, we measure noise. Finish. Okay, so measure. Okay, so generally we measure the noise. Okay, we finish. So now we inject noise to the product. Okay, to see whether the product died. Okay, your product maybe, so it depends whether your product depends on the category. Okay, whether your product cannot start or it will auto restart. Okay, or it can be failed or whatever. So it totally depends on the product standards. Okay, so they have a different criteria A, B, C, and D. Okay, so different product have different category. Same just now, immunity, we have different standards. Okay, so immunity is a bit misleading or confusing. In the immunity, you have product standard. Okay, so this product standard is about the product. Okay, what category of product you are in, and in each of the standard, they will call for another standard. Okay, which is the basic standard. So basic standard means the particular test. So this is only about one test, ESD, okay, RF related immunity, EFT burst, okay, surge, okay, RF conducted immunity, power magnetic, okay, and voltage deep drop and variation immunity. Okay, so I will go into each of them. Okay. So ESD, so I believe everybody experience what is ESD about. Okay, sometimes when you walk and walk and walk, when you touch the doorknob or you touch your car, you get a zap. Okay, so this is ESD. Okay, so it can be very high voltage, but it is always very low energy. Okay, so the testing is defined in 61000-4-2. Okay, so a few test level that we need to do is either level 1, level 2, level 3, or level 4. Okay, we have 2 kV, 4 kV, 6 kV for contact discharge. For air discharge, we are testing 2, 4, 8, and 15 kV. Okay, kilovolts. Okay, so it depends on what product. Okay, then you will use different test level. Okay, so we have a demo, okay, of this ESD generator outside. So if you are interested, you can have a look. And we have an expert from EMC partner as well, okay, for the ESD. So different kind of tests, okay. We have air discharge and we have contact discharge. Okay, so they test on a different area. Okay, then we have indirect discharge, okay, and we test on a different area as well. Okay, so for ESD, so we have a setup, okay, we have to follow that is defined in the 61000-4-2. Okay, we need to have a specific size of a table. Okay, 1.6 meter times 0.8 meter, and the height is 0.8 meter. Then you need to have a ground plane, you need to have a leader resistor cable. All is defined in the standard. Okay, so if you do the test according to 61000-4-2, you have to follow exactly the dimension of the test table that is defined in the standard. Okay, RF immunity, RF radiated immunity, 61000-1-3. Okay, so again, when you talk about radiated immunity, we have so many standards also. Okay, for commercial products, okay, typically we follow 61000-1-3. Frequency range typically is 80 megahertz to 6 gigahertz. Test level is not very high, 1 volt, 3 volt, 10 volt, 30 volts per meter. Okay, and of course we have automotive full vehicle radiated immunity, where the test level is typically very high. Okay, so start from 25 kilovolts up to 100 kilovolts, and some they do test up to 200 kilovolts, 200 volts per meter. Sorry. Okay, then for components, same. Okay, they do from 25 volts per meter up to some 200. Okay, some they do. So it totally depends on the product standards. And typically for radiated immunity, RF radiated immunity, we do in facilities, which is anechoic chambers. Then typical equipment we use is signal generators, okay, power amplifiers to amplify the signals, okay, and power meters to do the forward power and reverse power measurement, and of course the electric field sensor for you to detect what is the volts per meter you are doing. Okay, so same, we can use the anechoic chamber, okay, that we do for radiated emission, but we need to put absorbers on the floor, okay, in a semi-anechoic chamber, or we can perform in a full anechoic chamber with an absorber on the floor. Okay, next, EFT, electric fast transient or burst and surge immunity. So this test 61000-4-4 is defined to talk about electric fast transient. So imagine you're always in a switch in the light, okay? You on and off the switch, okay, very fast. Do you see a spark in the switch? Okay, a fire in the switch. Anybody seen before? When you on off the switch, okay, you will see. So this is actually a fast transient. Okay, so this is actually a very high voltage. If you, when I'm a kid, I play on off. Okay, I see the spark. This is actually high voltage. Okay, so you are actually giving high voltage to the power supply system that might potential, okay, to destroy some of the instruments that is connected. but as a kid, you don't know, okay, you just play, okay. So this is why we are doing this test, okay. So we purposely inject, okay, this pulse, okay. So this pulse is defined by the standard, okay. This is one burst, okay, means one high voltage, okay. So with a rise time of 5 nanosecond, 15 nanosecond, okay, then this is multiple bursts. So we inject many bursts, okay. So we inject this signal into the product. So we try to kill your product, okay. If your product survives, means the product is good, as defined by the standard. Okay, if your product fails, please go and check, okay, improve your product, okay. So usually occurs, okay, the fast transition usually occurs in manual switching, like I said, on off, on off, on off. This is manually switch, okay, or in automatic switching in the relay. Relay is on off, on off, okay. So you will create bursts as well, okay. Defined by the standard, okay, we need to do testing on the pulse platforms, okay. We also need to do in the I/O signals. Okay, so different test level depends on how critical your product is. Okay, audio video very less critical, usually at level 2. Medical products, okay, critical products usually at level 4. Okay, you need to survive. Okay, up to 4 kilovolts means that I inject 4 kilovolts into the product. Okay, to see whether your product survives or not. But in EFT, is if you see, okay, the rise time is very fast. The pulse width is very small. So it's very high voltage, but it is very low energy. Okay. So a typical setup that is defined in the standard, okay, you have to follow same ground plane, okay, then measurement distance. Okay, then another high voltage surge that is defined in 61000-4-5. Okay, so now this is another type of high voltage surge. Okay, so surge are typically very high voltage and also high energy. Okay, so they are dangerous. Okay, can be destructive. It can destroy your components. Okay, during the surge test. Okay, the pulse defined by the standard. Okay, so 1.2 microsecond. Okay, now the rise time is 1.2 microsecond with a pulse width of 50 microsecond. So this is one surge. Okay, so before is 4 example is 4 kV, but the rise time and the pulse width is 50 rise time. 5 nanosecond rise time. The pulse width is only 50 nanosecond. Now we are talking about 1.2 microsecond of rise time, and the pulse width is 50 microsecond. Okay, so it is almost 100 times, okay, of the energy. So that's why surge is a destructive test. Okay. Same, we are doing 4 level, so it depends on the product. Level 1, level 2, level 3, or level 4. Okay. So we have a solution, okay, from compliance testing up to 4 or 5 kilovolts, and of course we have a solution up to 6.6 or 8 kV, and we have depends on the product. We have CDNs 3-phase up to 200 amps. Okay, so it depends on the product that you are testing. So if you are just doing TVs, television, or some household equipment, probably a single phase is enough. If you are doing some industrial air condition, maybe a 3-phase power supply is required, then you will require a 3-phase CDN. Okay, so we have a demo of this surge and burst offsite as well. So you can come and have a look, then we can, if you have more questions, we can discuss. Okay, then we have RF conducted immunity. So means that now, this one is the noise. Remember, go back to the slide before, how the RF will flow, how the noise will flow. Okay, so it will flow in the power supply. Okay, the surge and burst. Now we are injecting the RF noise into the line. Okay, So whatever power supply line, or you have immunity on the data lines, whatever line is a USB line, your Ethernet line, okay, we inject RF noise into the line. So 3 category, mainly level 1, level 2, level 3. So now we talk in volt EMF. Okay. So typically the frequency range we are talking about for RF immunity for conductor range is 150 kilohertz to 80 megahertz. Some standard we do up to 230 megahertz. Okay. Then typically what we use is RF generators. Okay. Say RF power amplifiers to amplify the signal. Okay, so we have the coupling and decoupling network. So how do we couple the signal, the RF signal into the line? Okay, then we have a power meter or voltmeter to measure the test level, and another power meter to measure the forward power and reverse power. So we configure this in the systems. Okay, so for up to customer test level requirement. Okay, some customer will say I want 3 volt 3 volt EMF. Some customer I want 10 volt EMF. Some customer I want 30 volt EMF. So it depends. Okay, so this will all defined by how big the RF power amplifier will require. Okay, so the immunity testing diagram. Okay, so different kind of coupling device, how we inject the RF signals. Okay, either we can use CIP current injection probe. Okay, we can use EM clamp. Okay, or the preferred method by the standard is using coupling decoupling method. Okay, magnetic field. Okay, so go back to school. When you have a current, you have magnetic field, correct? So this is where when you have a current flowing, okay, you have magnetic field. Okay, so the higher the current, the higher the magnetic field is. Okay, so usually is by AC frequency. In Vietnam is 50 hertz. Okay, then typical occurrence is, for example, you have high voltage, okay, tower, okay, we transmit 11 kV, you transmit 33 kV, okay. So typically, okay, when you buy a house, okay, you do not want to stay near this tower, okay. So because usually the magnetic field near this tower is very high. So you are exposed to magnetic field for a long period. Okay, so if we can, okay, we typically do not want to stay near here. So as far as possible, of course. Okay. Then we have a few different levels, okay, of testing. Okay, that 1, 2, 3, 4, 5. So we have a long term, okay, or continuous field, or we have a short term or short duration. Okay, so we inject magnetic field up to 1000 ampere per meter. Okay, so how do we inject? Okay, so we have a coil. So we have a coil here. So we have an EUT. So we inject one side. So we inject one side of the product, and we inject another side, and we inject another side. Okay, or if the product is a big, okay, we need a big ground plate. Okay, then we inject field into the product. Okay. So example of a solution that we have, okay, a generators and a magnetic field coil. Okay, so this is how we do. So we will inject the current, okay, from here to the magnetic field coil, then to have inject the noise into the product. Okay. Last one, okay, voltage deep drop and variation. So in the power supply line, it is always not stable, okay, or especially when you have you turn on some high load, okay, like motors. Sometimes you turn on the motor or turn on something, the light start to dim. Okay, so when the light start to dim is because when you start something heavy, okay, high current, they takes more current. The voltage in the power supply line will reduce. for a short period. Then after that, it will go back up again. So for example, okay, by standard, okay, we want to test, okay, a drop of 40% and a drop of 70%. So the voltage, we need to simulate the voltage to drop from 100% to drop 40% or drop to 70%, okay, for a short period. So we want to see whether the product still behave normally or not during this test. Okay, so there is 3 kind of tests that we need to do. This is we call deep. Deep means a small drop of the voltage. Another one is the voltage is running 100%. Okay, for example 220, and we have a duration of 0. Okay, for a short period, and then go back up. So we want to see how the product behave. Okay, so depends on the product category. Some product during the short period, it cannot shut down. For a medical device, okay, it got to be still working. Okay, some product you can shut down. Okay, you can manually turn on, or it's auto restart. So it depends on the product standard. Okay, another one is voltage variation. Okay, so up and down, okay, for a long period. Okay, voltage variation. So for this test, okay, so defined in 61,000-4-11, okay, deep drop interruption and variation. Okay, so the standard defined, okay, typically 61,000-4-11 for 16 amps and below products, and 61,000-4-34 for above 16 amp products. Okay, so same depends on the product that you are designing. Okay, you are making. It depends which standard you need to follow. Okay, so some example solutions that we have. Okay, from an EMC partner. So there we go. We finish all the. This is just basic. There are more tests that is required in an EMC, but generally these are just the basic tests. Okay, we talk about RF, conductor, and radiated emission, where you do measurement in the chamber for radiated. Okay, we talk about harmonics and flicker. We measure noise in the power line, the harmonics. Now we inject RF noise, okay, the conductor and radiated noise, okay, to the product, and some high voltage tests to the product. So typically, these are just a brief overview about what EMC test is required for most products. Okay, that's all for my presentation for today. So if you have any question, you can come to me or any of our colleagues, then we can further discuss with you. Thank you.